The 36th America's Cup has introduced a complete new type of boat class, foiling monohulls, a new concept, new challenges, and little existing experience. How did modeFRONTIER help you in the preliminary design phase? Okay, modeFRONTIER helped us in the preliminary design phase really tremendously because, well, these boats are completely new. We didn't have any experience. And just one example was we didn't know at all how the hull should look like to have an easy takeoff. Actually, we didn't know how these boats would get onto the foils. And in order to explore that, we developed at the beginning with our simulator a takeoff sequence that was controlled by modeFRONTIER. Then we used these optimized takeoff sequences to define a cost function that represented the quality of the takeoff phase. And then we used that cost function in a hull optimization that was also run with modeFRONTIER. And within the hull optimization, we ran that in several loops. So at the beginning, we explored a very wide design space because we didn't know anything about these boats, but with less details. And then we introduced slowly more and more details to describe the hull shape and reduced the size of the design space. So all this took us, I would say, about 3 months. And without modeFRONTIER, it would have been impossible. I think without modeFRONTIER, it would have taken ages, and we never would have found the very unusual hull shape that we found at the end. It was actually a hull shape that came out that none of us had expected before. So that was a huge, I would consider a big success, and it was really thanks to modeFRONTIER that we found this kind of hull shape. Okay, multi-fidelity and multidisciplinary optimization has become a crucial aspect in the design of complex systems like the foiling monohull. How did you use modeFRONTIER's capabilities to address these topics? Well, we used in order to address multi-fidelity optimization, we actually ran optimizations on different topics in which we varied some of the input parameters that went into the optimization. So, for instance, for a hull shape, for a hull shape or also foil design, we defined certain boat speeds and certain loads for those speeds. And since we didn't know exactly if those were the real numbers, we varied them and then ran several optimizations with different input parameters, and this gave us this allowed us to take somehow into account uncertainties, and therefore this gave us confidence that in the end the shapes that came out of this optimization process were not just optimized into a small local minima, but that they represented really hopefully a global minima, but at least a big minima. And this is how we did it. And the last one, so the America's Cup is a highly competitive environment where the time may be one of the most important factors along with the performance. Could you tell us about any time saving and performance enhancement obtained with modeFRONTIER? Well, we used modeFRONTIER in the optimization of hull shapes, foil shapes, but also in order to optimize sailing techniques. And in all those fields, modeFRONTIER allowed us to explore a much wider design space within a given amount of time than what we could have done without the usage of such a powerful optimization tool. it's on one side, actually, time and performance are very closely linked in an America's Cup campaign, because we have a limited amount of time, and so if you have a very fast tool that allows you to explore within a given time a wider design space, then for sure you will in the end get a better and faster boat. So time and performance is closely linked, and modeFRONTIER allowed us to explore within the given time frame we had the for us the biggest possible design space, and therefore get the most out of the time that we had.